One important factor with 134A refrigerant is in how it breaks down from overheating. If you've got a system that's run for quite a while with a low side leak, or if in recovering the refrigerant out of the system you found oil that's dark brown in color, you'll need to replace the dryer. But that's only true with 134A. R12 isn't a problem. Here's why. R12 refrigerant uses mineral oil and, when overheated, breaks down into carbon that builds up at the head of the compressor. If a piece of carbon breaks loose, it's large enough that the dryer filter will catch it before it gets into the cap tube. 134A, on the other hand, contains ester oil, and when overheated, ester oil breaks down into a fine powder, a form of salt. That powder will slip right by the screen in the dryer and build up in the first 6 inches of the cap tube. So if you've got a 134A system that's overheated, you should not only replace the dryer, but also about 6 inches of cap tube. Go ahead and cut the dryer off first. That will make it easier to work with the cap tube. Now, factory-installed dryers will have about 1.5 inches of capillary tube inside of them, so you'll only need to measure about 3 to 4 inches here. The cap tube is too small to cut with a tubing cutter. The cutter will collapse the end. So what you need to do is just score the tube with a file and break it off. Check to make sure that you've got a clean break inside here. You can't have any restrictions in this tube that would affect the flow of refrigerant. Never sweat the dryer off to preserve tubing. Your torch will heat up the desiccant in the dryer. The desiccant will release the moisture that it has absorbed and you'll contaminate the system. Always cut the dryer out of the system. On badly contaminated systems, replace the dryer with a special service dryer containing a section of activated aluminum ahead of the standard desiccant. The aluminum helps remove acid from a badly contaminated system. The desiccant removes moisture. It's very important that you install the dryer with the inlet above the outlet. Refrigerant must be pushed up the capillary tube. Be sure and get 1/2 to 3/4 of an inch of capillary into the dryer to assure that you don't weld the end of the cap tube shut. Insert about 1/2 inch of the hot tube outlet into the dryer filter. You should remove the Schrader fitting before you start welding. Even though the valve is far enough from the point of the weld to avoid damage, it could be affected by accidental exposure to the flame. When the joints have cooled to safe temperature, tuck the dryer into the cabinet. You're now ready to evacuate and charge the system. It's important to understand that ester oil soaks up water at a rapid rate. Anytime you encounter a low-side leak, you can assume that the compressor is contaminated with water-laden ester oil and must be replaced. Start by making cuts on the suction line and the compressor discharge line. When replacing a compressor, you should also replace the starter and running capacitor. The starter is a one-piece package that contains both the relay and the overload. The running capacitor plugs into the back of it. This is a running capacitor only. The product will start and run without it. So don't assume that it's working just because the product is running. When this capacitor is open, the compressor draws more current and generates more heat. Your replacement kit will be listed as either with electricals or without, so you will know whether or not you need to order them separately. After removing the electrical package and cutting the high and low lines, remove the 3 bolts holding it down and move the compressor forward a little. This will provide a little more clearance to remove the ground wire. Depending upon the age of the product, you may find that the replacement compressor looks different from the original. Older units were built with an Americold compressor. Today, replacement compressors come from either Embraco or Tecumseh. You'll find that the line configuration on Embraco compressors is different than Americold and Tecumseh. Americold and Tecumseh feature suction, discharge, and process lines here. Embraco configures these lines like this. You can reference your literature for further details. You will need to transfer the rubber grommets from the old compressor. You'll also need to unsweat the crossover line and reuse it on the new compressor. Then it's just a matter of making the line welds, evacuating the system, and dumping the new charge. Most refrigerators take the last pass of the condenser coil and run it around the front of the cabinet. The warm gases prevent moisture buildup on the refrigerator gasket. This is referred to as either a post-loop condenser or simply a hot tube. When a hot tube develops a leak, there is no way to stop it and no way to replace the tubing. Frigidaire makes a hot tube repair kit that consists of a braided nichrome heater wire that can be pulled through the tube and wired into the system to come on whenever the compressor runs, providing the same warmth as that of the hot tube. While this may at first appear to be a daunting task, with the right technique, it becomes easy. The first step is to cut away the dryer. You'll need to weld in a new one later. Then cut the hot tube right above the sleeve weld coming out of the condenser. You've now isolated the hot tube from the rest of the system. Next, you'll pull the heater wire through the tube using your vacuum pump. First, completely unwrap the wire. Carefully straighten it, ensuring that there are no kinks or knots. You'll find that it consists of two sections, a 20-foot braided wire with electrical connections, and 20 feet of braiding with no wire in it. This braiding is what you will feed into the tube first. Then, you will use it to pull the braided wire through. Using a small rag saturated with vacuum pump oil, wipe the entire length of wire and the braiding. This will both lubricate it and straighten out any kinks. Now, tie a number of knots at the very end of the hollow braiding. How many knots depends on how you tie them. You'll want to end up with a knot that's a little smaller than the tube. It will act as a plunger with the vacuum. It doesn't matter which way you pull the string through the hot tube, but whichever side you enter through, make sure that you ream the opening to a very smooth consistency. You'll find a white tube included with your kit. Slide this tube over the other end, that is, the exit end of the tube. Then connect your vacuum pump to the plastic tube. This tube will let you see when the braided string comes through so that you don't suck it into your vacuum pump. Turn the pump on and just feed the string through. Keep it taut as it goes so that it doesn't ball up somewhere inside the tube. You'll need to occasionally pull it back a little and then release it. If it completely stops moving, then cover the opening and begin drawing a vacuum. When you hear the pump load up, let go and it will begin moving. If this just isn't working for you, check the plastic tube. If it's leaking, you may have to remove it and go without it. If you're still having problems, try going the other way. And remember, when working without the plastic tube, be sure to pull the vacuum line off frequently, checking to see if the string is through. Once you've got the string through, use it to pull the wire section through a little at a time. Run the fixed end across the back of the unit to the compressor relay wires. Cut the excess off the other end. Strip a couple of inches of braiding off the end and double this thin wire over a couple of times. Attach a butt connector and then attach the wire connector provided with the kit to the butt connector. Now you can tie the heater in, one end to the light blue neutral and one end to the red power. The heater will cycle right along with the compressor. Next, you'll need to close the system up. Start by cutting the sleeve weld off the condenser. Slip the provided 1/4 inch tubing over it and run it across the back of the unit toward the dryer. Okay. Now, before you cut the ports on the surface dryer filter, you need to reshape the output. You need to bend it around to reach the shortened cap tube. After cutting the tubing, you may have to ream it out for it to accept the cap tube. Once you've got everything in place, make the line welds and it's ready to pump down and recharge. Because of the high pressures involved with nitrogen tanks, you must use a pressure regulator when flushing with dry nitrogen, and you must use sweat-in valves. The regulator and the hoses must be in good condition. Ensure the hoses aren't frayed or swelled at the connections. You have to flush the high and low side separately. Cut out the high side at the compressor discharge and the hot tube discharge at the dryer. Most servicers like to cut in right at the point where they attached a line tap, so they don't have to weld that hole later. Connect a sweat-in valve to the hot tube discharge. You'll connect here so that you can flush the system in the reverse direction of its normal flow. Be sure to remove the Schrader valve stems if you're sweating these connectors on. The heat from the process will ruin the valve seats. Leave these stems out during the flushing process to provide greater flow through the system. The high side cannot take more than 250 pounds of pressure. Open the regulator until the pressure reaches about 200. That's sufficient to do the job. Place a white cloth over the other end of the tubing to see what's coming out. A contaminated system will flush out dark brown burnt oil. Continue flushing until what comes out is clean and free of contaminants. Then close the regulator and wait until the system bleeds down the remaining nitrogen. Flushing the low side is the same except that the pressure on the low side cannot exceed 150 pounds. In addition to looking for a clean discharge from the cap tube, you are also looking for a good strong flow out of the tube. Once you've got that, shut down the regulator and disconnect your equipment. The next step is to reconnect the system, pump it down, and recharge it. Flushing with 134A has some drawbacks, one of which is the need to recover that refrigerant as you flush. So, flushing with 134A requires using two process tools on each side. This procedure is designed to flush each side with 8 ounces of refrigerant so that a high side flush and a low side flush will total 16 ounces and will fit into a 24-ounce recovery bag along with the 6.5 ounces of refrigerant that you may have recovered from the system already. It's critical that you not overinflate these bags. Doing so by as little as 2 ounces may rupture the bag. First, cut out the high side at the compressor discharge and the hot tube discharge at the dryer. The cap tube is too small for a tube cutter, so etch it with a file and break it off. And make sure you haven't collapsed the opening. Connect a process tool to each end, or if you use sweat-in valves, be sure to remove the Schrader valve stems before sweating these connectors on. The heat from this process will ruin the valve seats. Leave these stems out during the flushing process to provide greater flow through the system. Connect the recovery bag here and the dial-a-charge here so that you can flush the system in the reverse direction of its normal flow. Open the dial-a-charge and open the valve. Continue flushing until the discharge into the bag is clean. Then shut off the dial-a-charge and let the remaining refrigerant drain into the bag. Next, connect to the low side at the compressor suction line and at the cap tube and connect process tools. It's important to flush in the normal direction of refrigerant flow on the low side. Feeding refrigerant in the opposite direction would increase the chances of contaminants getting caught in the cap tube. Open the dial-a-charge and then the valve and watch the discharge flowing into the bag. When it's clear, you can shut off the dial-a-charge and let the system bleed down. But if you've encountered a badly contaminated system in which the oil is dark brown and of a sugary consistency, you may not have enough pressure with 134A to blow the contamination out through the cap tube. In these situations, you'll save time by simply replacing the evaporator.